In this video, we're going to take a look at solving a system of equations. But this time, rather than graphing or using substitution, we're going to use another method called elimination. In elimination, our main goal is to eliminate one of the variables. So to eliminate either the x or the y. In order to do that, what we need to do is we need to either add or subtract the two equations so that the x or the y is eliminated. In this case, I'm always going to recommend to students that we add the two equations. My reasoning for that is that in adding the two equations, we have less room for error. So while you can subtract the two equations from each other, I'm always going to advise you to add the two equations together. So looking at these two equations, if I were to add them together right now, 2x plus 1x would be 3x, negative 3y plus 2y would be negative 1y, and 4 plus 2 would be 6. So as these equations are, no variables would be eliminated. So what I need to do is I need to choose one of the variables, and I'm going to multiply one of the equations, or both of the equations, by a number in order to make it so that when I add them together, the variable will be eliminated. For example, the easiest thing to do here is to choose this second equation. And I'm going to decide to multiply this whole equation by negative 2. Now how did I determine that? Well, if I look at the top equation, I have 2x minus 3y equals 4. If I look at the bottom equation, when I multiply by negative 2, my x is going to become negative 2x. And that right there is the key, because 2x plus negative 2x, now they're going to eliminate. The y becomes negative 4y, and that's okay. The coefficient on the other side becomes negative 4. So I'm going to add these two equations together. 2x and negative 2x is 0x, so that in essence goes away. There's no reason for me to even have to write that. Then I have negative 7y equals 0. I'll divide by negative 7, so y does equal 0. Now how do I find x? The same as we've always done. I'm going to choose one of my two equations. I'm going to plug in the 0 for the y, and I'm going to solve for x. So then 2x equals 4, x equals 2, and my solution is 2, 0. So let's try that again. Now in this example, I notice that on the top equation, I do have the x and the y on the same side. But on the bottom equation, I have the x and the y on opposite sides, and this is a problem. Because with elimination, in order to add two equations together, I need the different variables to be lined up on top of each other. So I need to move this 4x over, and I need to move this negative 4 over to the other side. Not only am I going to move the 4x over to the left-hand side, but when I move it over and it becomes positive 4x, I'm going to write it in front of the positive 2y. And then I move the negative 4 over, it becomes positive 4. So my new system looks like this, and now I like the fact that my x's and y's are all lined up together. So now I'm looking at my x's don't match, my y's don't match, my numbers don't match. I need to get rid of one of my variables. Well, the simplest thing for me to do is I'm going to take that bottom equation and I'm going to multiply it by negative 3. Why negative 3? Not to get rid of my x's, but to make my 2y into, I just realized I should be multiplying by a positive 3 rather than a negative 3. This way, I'll have a 6y, which will be the opposite of the negative 6y right above it. So in the top I have 3x minus 6y equals 18. My bottom equation is going to become 12x plus 6y equals 12. I'm going to combine those two equations by adding them. I'll get 15x equals 30 because my y's cancel. X equals 2. And now going back, let's plug it in. So 3 times 2 minus 6y equals 18. So 6 minus 6y equals 18. So negative 6y equals 12, and y equals negative 2. So my solution here is 2 comma negative 2. And of course, let's try one more example. The interesting thing about this example is everything is lined up, but if I look at my two equations, there's nothing that I can multiply a single equation by that will change my coefficients to be opposites. However, I can certainly multiply both equations if I'd like. So I could take the top equation, multiply it by 3, take the bottom equation, multiply it by negative 2. That would help me to eliminate my x's. Could I have chosen to eliminate my y's? Yes, but in that case I would multiply the top equation by 5 and the bottom equation by 4. Notice it's only coincidence that we're choosing to multiply by the number in front of the other equations x or y. Sometimes it does work out that way, but that's not always the simplest thing to do. Let me rewrite my equations. 6x minus 12y equals 30, and negative 6x minus 10y equals 14. That's going to give me negative 22y equals 44, and that's going to give me y equals negative 2. Now solving for x, so 2x minus 4 times negative 2 equals 10. 2x plus 8 equals 10. 2x equals 2. X equals 1. So my solution is 1 comma negative 2.